Hello everyone, welcome back to my channel. So in this video we are going to discuss about round robin scheduling. So round robin scheduling basically revolves around a time quantum. So what is a time quantum? So we decide a particular time quantum. Let's say we decide some x. So after every x we pick up a process that is next in queue. And how would that queue be? So that would be a circular queue. So we will assign all processes in a circular queue, and then at every x time quantum we will change, or that is we will pick another process from the queue. Now in this what happens is that the average waiting time can be higher, but the response time is good. And then now we'll understand this point later in the video, that what happens when it is sensitive to time quantum in smaller sense and in larger sense. So now let's understand this scheduling algorithm with the help of an example. So let's look at this example where we see there are three processes, P0, P1, P2, and we have been given their arrival time and burst time respectively. And let's say that the time quantum that we have got is equal to 2. So first of all we will have a circular queue. So we have P0, P1, P2. So it would be like from P0 to P1, then from P1 to P2, and then again from P2 to P0 according to the arrival times. So because firstly P0 will come in, and then P1 will come in, and then P2 will come in, so we will make this circular queue. Now let's start with time t is equal to 0. So time t is equal to 0, since we have only P0, so we have it, we allocate it. Now since the time quantum is 2, so after time 2 P0 gets terminated. So then it moves to P1, because P1 has also entered by this time and P2 has also entered. So now we are at P1. So what happens when P1 comes in? So P1 has a burst time of 1. So P1 completes at time 3 only. So now since it's completed, we will remove it from the queue. So now it's P0 to P2 and P2 to P0. So after it's removed, since we had the next element in queue as P2, so we are at P2. So P2 gets allocated, and then after 2 units of time it also gets terminated. It doesn't get terminated, it gets preempted. Pardon for earlier as well, I said here also that P0 gets terminated, rather it gets preempted. P1 got terminated at 3. Then so after P2 gets preempted at 5, then we move on back to P0. So now after 2 units of time has been completed, 1 remains, and here also this becomes 0 and this becomes 3. So 1 unit of time, so P0 takes 1 more unit of time, so it comes at 6. Then after P0 is completed, only P2 remains, so it consumes whole of its time and then gets completed at 9. Now let's look at the turnaround time and waiting time and response time for these. So first of all let's look at the turnaround time. So turnaround time is basically the completion time minus the arrival time. So the completion time for P0 is at 6, so 6 minus 0 becomes 6. Then for P1 it gets completed at 3 and its arrival time is 1, so 3 minus 1 is equal to 2. And for P2 it gets completed at 9 and arrived at 1, so turnaround time is 8. Now let's talk about the waiting time. So waiting time is basically turnaround time minus burst time. So here we have 3, 1 and 3. Then talking about the response time. So we saw that P0 arrived at 0 and it got immediately allocated, so response time would be 0 for this. Then P1 came at t is equal to 1 and got allocated at t is equal to 2, so 2 minus 1 would be 1. Then for P2 it gets allocated at 3 and it came at 1, so 3 minus 1 would be 2. So this is the overall process: arrival time, burst time, turnaround time, waiting time and response time. So we can also calculate the average waiting time and average response time. we can see here that the average response time is quite less. So that's all about round robin scheduling. It's basically a preemptive scheduling algorithm. That's it for this video. Now we're left with one more scheduling algorithm which we'll finish in the next video.